Hello students, today we are going to discuss GJMAT 2021-22 grade 8 paper. Alright, so before we proceed, we'll just go through the format once of this examination. This question paper has 25 questions overall, which are all MCQ, multiple choice questions with 5 answer options and single correct answer. Question number 1 to 10 are around conceptual understanding, which are 2 marks each. Then question number 11 to 20, 10 questions are around application ability, 4 marks each. And question number 21 to 25 are problem solving and critical thinking skills, which are 8 marks each. There is no negative marking, so one can attempt all the questions without, all the questions. Duration of this exam is 1 hour. Apart from this, apart from any basic exam rules, you are not supposed to use any calculator, but you can use any rough sheets or paper to solve the questions. All right, so without any further ado, we'll start with the question paper solutions. So, section A, conceptual understanding, question number 1. If 64,800 multiplied by A multiplied by B is equal to C cube, where A, B, and C are positive integers, find the smallest possible value of A plus B plus C. So, first of all, we need to understand that if we are multiplying this number by two numbers, okay, and we are getting a cube, so the smaller the C, the smaller will be A and B as well, correct? All right, so our objective is to find a number, two numbers which we multiply with 64,800 and we should get a perfect cube. So for that, first of all, what we need to do is to prime factorize 64,800. All right, so 64,800. All right, if we divide by 2, we get 32,400. Divided by 2, we get 16,200. Divided by 2, we get 8,100. All right, divide by 2 again, we get 4,050. Divide by 2 again, we get 2025. Okay, now we cannot divide any further by 2 because the last digit is an odd digit. Okay, but the sum of the digits is 9. So using divisibility rule, maybe we can divide by 3. Okay, so we'll divide this by 3. We'll get 675. Yes, we'll get 675. Divide it again by 3 because the sum of the digits is 18. We'll get 225. Divide by again by 3. We'll get 75. Divide by 3. We'll get 25. Divide by 5, we'll get 5. So 6,400 and 800, 64,800 is 2 is appearing 5 times, 2 raised to the power 5 multiplied by 3 raised to the power 4 into 5 square. All right, so this is the prime factorized form of 64,000. Now, we need to understand that if we are multiplying something, okay, if there's a C here, okay, so the minimum value of C, whatever C will get, okay, it will definitely have the 2, 3, and 5 as primes because these are already existing with 64,800. Okay. So if you are looking for the smallest value of C, we need to include these primes. But here the power is already 5. Now understand in a cube number, for example, if this number was 2 into 3 into 5, when we cube it, what will happen? It will become 2 cube into 3 cube into 5 cube. So these powers will be always multiples of 3. All right. If we had a 2 square here, for example, if we had a 2 square, this would have become a 2 to the power 6, 2 times 3. Right. So we need to understand that the powers will be always C cube. C cube will always have the powers of each prime as multiple of 3. Now the minimum we can get for a multiple of 3 for 2 to the power 5 is 2. Okay, because, 1. So it will be plus 1 will give me a 6, correct? So I need a 2 from here, right? And then for this one, I need a plus 2 here. So I need a 3 square here, all right? And for the 5 square, the next multiple of 3 is 3 plus 1. So I need a 5 here, all right? So A into B can be these. When we multiply this number with 64,800, we are going to get 2 raised to the power 6 into 3 raised to the power 6 into 5 raised to the power 3. All right. Now, this is equal to c cube. Therefore, what will be the value of c? Therefore, the value of c is going to be, if we take 1/3 of these powers, we'll get the value of c, which will be 2 square into 3 square into 5. All right. And this number is going to be 4 times 9, 36 times 5, which is 180. All right. And what about A and B? A and B, if you notice, product of A and B, if you notice, it will be 2 into 3 square into 5, which is 2 into 9, which is 18 times 5, which is equal to 90. All right. Now, our objective is to find a minimum value of A plus B plus C. Okay. Now, C we already found out, which is going to be 180. What about A times B is 90. So, for the minimum value of this, we need to have two numbers which are very close to each other, so that their product is 90, but their sum is minimum. All right. So, that will be 10 plus 9. So, we can assume that A is greater than B, and 10 plus 9 plus 180. And therefore, your answer is going to be 199. All right. So, I hope you understood the solution. So, the answer over here is option E, which is 199. Right. Let's go to the next question. Question 2. Solve the equation for the value of x where x is real. Log with the base of 3x 1296 is equal to 2x. All right. So, we know when we have a logarithm, so for example, we have log to base 4 is equal to 2, which means that if you have a number, okay, a to the power b is equal to c, then log of c to the base a is equal to b, right? So this much concept you should know. Okay, basically it throws the exponent. Okay, when you take the value of this. So in this case, what we'll get is that x to the x 3x is the base raised to the power 2x is equal to 1296. All right. Okay, which we can see here that we can distribute this as we'll first do a prime factorization of 1296 just to understand that what this number is. Okay, so we'll do a prime factorization of 1296. So 1296 divided by 2 will give me 648, divided by 2 will give me 324, divided by 2 will give me 162, divided by 2 will give me 81, divided by 3 will give me 27, divided by 3 will give me 9, divided by 3 will give me 3. So, your 1296 is equal to 2 raised to the power 4 multiplied by 3 raised to the power 4. All right. Okay. Now, we are going to distribute this because 3x raised to the power 2x is equal to this much. All right. So, we are going to distribute this is going to be 3 raised to the power 2x into x raised to the power 2x is equal to 2 raised to the power 4 into 3 raised to the power 4. All right. If we compare this, we see that if we compare the base of 3 with the 4, so we get 2x as 2x is equal to 4. Correct? And therefore, x will be equal to 2. And we can check this out also. If we put over here 2x, 2 over here, if we take this x as 2, then 2x is again 4. Correct? So that becomes 2 raised to the power 4. This one will be equal to this. And this one we already established that this one is equal to this. So therefore, x is the value of x is going to be 2. And the question was asking that we have to solve this equation. So solving the equation is always for the unknown. Okay. So solve the value of x, right? So the correct answer is option A, which is 2. All right. Let's move on to the next question. Question 3. Find the value of x over y for the below system of equations. The first equation is x plus 3y over xy is equal to 5 upon 12. The next equation is 2x minus 3y upon xy is equal to 1 upon 12. All right. So what we'll do is that first of all, from taking the equation 1 here, we'll try to do a cross multiplication and see what happens. So 12 times x is 12x plus 36y is equal to 5xy. All right, we did a cross multiplication and we got this. Okay, similarly, we'll do a cross multiplication here as well, and this one will give us 12 times 2 is 24x minus 36y again is equal to xy. All right. We can add these two equations because we see 36y and 36y are here. So if we add both these equations, these will cancel out and we'll get 36x is equal to 5xy is equal to 6xy. Sorry. 5xy plus xy is 6xy. We can cancel out the x and we'll see that y will be equal to 36 upon 6, which is equal to 6. All right. So we've got the value of y. Now we'll try and plug in the value in one of these equations to find the value of x as well. So we see if we plug this value of 6 in the first equation, we'll get 12x plus 36 times 6 is equal to 5 times 5x into 5x multiplied by 6. All right, so let me put the multiplication sign as a dot here so that you don't get confused. 36 dot y. All right, so here we see here that 36 times, sorry. So the y's value we have already found out, 36 times 6. All right, so therefore 12x will be equal to, so we can take this one on this side. So 18x, if you take this on the other side, so 18x is equal to 36 times 6, which is going to be 180 plus 36, which is 216. And therefore, x will be equal to 216 divided by 18, which will give you 12. Right? So we found the value of x and y. So the value of x over y is going to be 12 over 6, which is 2. And correct answer is option B, which is 2. All right, so we'll move on to the next question. Question 4. How many natural numbers from 1 to 100 can be expressed as difference of two perfect squares? For example, 27 is 14 square minus 13 square. All right. So first of all, let's understand what the question is saying. So there are overall 100 natural numbers. Okay. Now, how many of them can be expressed as difference of two squares? Two perfect square numbers. Perfect square numbers are squares of integers. All right. So let's understand one thing, that every odd number can be expressed as difference of two squares. The reason being that the form of an odd number is 2n plus 1, right? Where n is some integer, correct? Some positive integer, right? Okay. In fact, a whole number. You can put a 0 also and you'll get the 1, right? So 2n plus 1, that is the form, because it's one more than an even number, right? Okay. Now what you can do is that you can add a n square before the 2n, and then you can subtract a n square as well. Okay, because then you are not changing the value of 2n plus 1. You're adding a n square and you're taking away a n square. Right? Now this one over here is of the form of n plus 1 whole square. So if you know, a plus b whole square is equal to a square plus b square plus 2ab. So if the n is a, then you have the n square, and if the 1 is b, then it is plus b square. 1 square 1 square will be 1 only, and then 2 into n into 1 will give you a 2n. So this is n plus 1 whole square minus n square. And since n is a number, is an integer, so n plus 1 will be also an integer, and n will be also an integer. As you can see in this example also, if the 2n plus 1 is equal to 27, therefore 2n is equal to 26, and therefore n is equal to 13, and therefore you can see that here n plus 1, therefore n plus 1 will be 14, and you can see here 14 square minus 13 square is 27. Okay, this will be there definitely, but there can be other possibilities also for an odd number. It completely depends upon what that odd number is. Okay, so I won't get deep into that. Okay, but it will be definitely, it can be expressed as two perfect squares, which will be of this form. One of them will be of this form. Okay, now what about the even numbers? Let's understand that. For an even number to be perfect square, okay, so let's understand, let's say there is an even number e, and it is a difference of two numbers, a square minus b square. Okay, where a is greater than b, where a is greater than b. All right, now let's understand this, that this is also equal to a plus b into a minus b. I'm sure that most of you would be aware of this, that a square minus b square is a plus b into a minus b. Now let's understand this. They have to be of the same parity for this to be an even number, because if A is, let's say, odd and this is also odd, then the sum of this is even. Correct? And if this is odd and this is odd, then their difference is also even. So they are of the same parity. So even times even will give you an even. But at the same time, if we check with the other numbers also, I mean other type of, give me a second. If you check with the other type of parity also, which is the even parity, so even plus even is even and even minus even is also even. So therefore, their product will be an even number. Okay, but what happens if you take one of them as even and one of them as odd? Okay, so you know odd minus even or even minus odd are both odd. So let's take the larger number as even. So this one will become odd, right? Even minus odd number, a plus b will become odd, and even plus odd, and even minus odd will also give you an odd number, right? So in that case, an odd times odd is never even number. So there is a contradiction, correct? Which means what? Which means that this part over here, whenever the parity is same of a and b, this part over here is going to be even into even. All right. And therefore, this number will be of the form of, let's say, 2m, 2 times m, because it's an even number. And similarly, this might be of the form of 2 times n, let's say. All right. So that this even number will be of the form of 2m multiplied by 2n. It will be 4 times m into n. And therefore, this even number will be always a multiple of 4. Okay. So the multiple of 4 can be expressed as a difference of two squares. Okay, any multiple of 4. But the even numbers which are not multiple of 4 cannot be expressed as a difference of two squares. For example, 10. 10 is an even number, but it's not a multiple of 4. Therefore, it cannot be expressed as difference of two square numbers. You can check this out and you can find out any two square numbers. So, for example, if we look at uh, 25 minus 16, okay, which are two consecutive square numbers, 5 square minus 4 square, you get 9. Okay, the next one you will get is 36 minus 25. Okay, these are the closest square numbers, you will get 11. So 10 is getting skipped, correct? Right? At the same time, if you look at 12, 12 can be a difference of two square numbers. Now, how can we find this? So we can say that, okay, 12 is a plus b into a minus b. All right. Now, a plus b and a minus b, in how many ways we can take it? We can take it's either a 12 and a 1, 12 times 1. But this we cannot consider. Why? Because the parities are different. One is of even parity, the other is odd parity, right? Then we can have a 6 times 2, and then we can have a 4 times 3, correct? And we can have a 6 times 6. But 6 times 6, if we take it, okay, so a minus b is also 6 and a plus b is also 6. Okay, which means that b is 0, correct? Not 6 times 6. I'm very sorry about that. We are talking about 12 here, right? So it's 4 times 3. Okay, so 12 has got how many factors? First of all, let's understand 12 is 2 square into 3. So 12 has got 3 times 2, which are 6 factors, and we've listed all the 6 factors with 3 pairs. Now, this one only we can consider because both of them are of even parity. As we discussed that both of them will be even parity. So you can see here that 6 square, okay, 6, a plus b is 6. So a plus b is 6 and a minus b is 2. If you add it up, you get 2a as 4, as 8, and therefore a is 4. And therefore b is going to be 2. Therefore, b is going to be 2. And therefore, you can see that a square minus b square is going to be a square minus b square is 4 square minus 2 square, which is 16 minus 4 is equal to 12. All right. So, we understood that all odd numbers can be considered. So, how many odd numbers will be there between 1 and 100? There'll be 50 odd numbers, correct? 50 of them will be even and 50 of them will be odd. And how many numbers are multiples of 4? That is from 4 to 100, there are 25 multiples, right? So those 25 multiples which are multiple of 4, those even numbers. Okay, so 25 plus the 50 odd numbers. Your correct answer is 75. And that's your answer. All right. So let's move on to the next question. I hope you understood the concept as well. Find the positive difference of the roots 6x square plus 12x minus 48. Now, what are roots? Roots are the solution for this equation. Roots means for the values of x, this equation will be true, right? So a quadratic equation typically has two roots or two solutions, correct? So let's try get going with the equation. We have 6x square plus 12x is equal to 48. All right, bringing the 48 on the other side will give me 6x square plus 12x minus 48 is equal to 0. Dividing both sides by 6, because we see all the coefficients are multiples of 6. We'll get x square plus 2x minus 8 is equal to 0. All right. Now here we see that 1 into minus 8 is minus 8. How can we do this as a plus and minus? So you can have this as x square plus 4x minus 2x minus 8 is equal to 0. We are going to apply simple factorization here, okay, which will give us x common x plus 4 minus 2 common x plus 4 is equal to 0, and therefore we can say that x plus 4 is common in both of them. So we'll take x plus 4 as common and we'll get x plus 4 to x minus 2 is equal to 0. Therefore one of these terms have to be 0. Therefore the values for this equation will get satisfied for x. So x can be, if x plus 4 is equal to 0, that gives us x is equal to minus 4, and if x minus 2 is equal to 0, that gives us x is equal to 2. Right now, the question is asking, find the positive difference of the roots. So your roots are minus 4 and minus 2. Okay. So on the number line, 2 will be here, minus 4 will be here. And the difference over here is going to be 2 minus 4, which is going to be 6. So that's your positive difference, which is 6 here. Okay. So your correct answer over here is 6. There is another way you can look at it using the sum of roots also. Okay, so when we simplified this equation and we got x square plus 2x minus 8 is equal to 0. Okay, sum of the roots of an equation of ax square plus bx plus c is equal to 0. Let's say the roots are alpha and beta. These are the two values of x for which this equation is true. Alpha plus beta. Then alpha plus beta, the sum of the roots is always equal to minus b upon a from this equation. And alpha beta is always equal to c upon a. Okay, so minus b upon a, if you take over here, so b is 2, therefore minus b is minus 2 by 1. So this one is equal to minus 2. And in this equation, in this one, c upon a will be minus 8 by 1, which is minus 8. All right. Now you know that alpha, now if we use this, okay, and we try and find alpha minus beta whole square, okay, this is equal to alpha plus beta whole square. That is, a minus b whole square is equal to a plus b whole square minus 4ab. It will be minus 4 alpha beta. Plugging in the value of alpha plus beta over here as minus 2 whole square minus 4 and alpha beta as minus 8, will get us, this one will become 4 and plus 32. That is 36. Okay, so therefore alpha minus beta will be equal to square root of 36, and which is equal to 6. This is another way of finding out alpha minus beta as well. Okay. All right. So we'll move on to the next question. I hope this one is clear. See the following discontinued fraction equation. 11 by 5 is equal to a minus 1 by b minus 1 by b minus 1 by b minus 1 by b. Find the smallest value of a plus b where a and b are positive integers. So this is a layered fraction problem. Okay. We'll try and solve this. Okay. So first of all, we'll start from here. Okay. So here we see 11 upon 5 is actually 2 whole 1 upon 5, right? But 2 upon 1 upon 5 can be written. So 11 upon 5 is equal to 2 upon 1 upon 5. Okay. But we have something minus here. Okay. So we cannot write this as 2 plus 1 by 5 if you are comparing these two. So we can write this as 3 minus 4 by 5. All right. So at every step, we are going to apply this logic. Okay, where we are going to take the next integer and then, write the fractions, write the, the proper fractions as a difference of an integer and a proper fraction. Okay, so therefore 11 upon 5 is equal to 3 minus 4 upon 5. All right. So from this we can directly we got the value of a and we'll just write it down and we'll keep it with us. So a is going to be 3. All right. Now this one, how we need to write is that we are going to flip the fraction because we have a reciprocal here. We have a 1 here on top. So we'll write this as 1 by 5 by 4. Okay. And this one will become 3 minus. Now 5 by 4 is 1 whole 1 upon 4. Or we can write that as 2 minus 3 upon 4. We applied the same logic here. 2 minus 3 upon 4. All right. Is equal to, we are going to write this as 2 minus, again we are going to take this reciprocal here and we are going to write this as 1 upon 4 by 3. All right. So we'll move forward and we'll write this as 3 minus 1 upon 2 minus 1 upon, now 4 by 3 is 1 whole 1 upon 3. Okay. Which means that it is 2 minus 2 upon 3. 2 minus 2 upon 3. And we are going to write this then again 3 minus 1 by 2 minus 1 by 2 minus, again we'll put a 1 here and we'll flip this fraction and write this as 3 by 2. Right? Okay. I'm not going to, and this part only I'm going to change this time. I'm not going to write it again. 3 by 2. So 3 by 2 is 1 whole 1 upon 2, which is 2 minus 1 by 2. All right. So now if you compare this with the original fraction here, okay, let me make this a little smaller. If you compare this over here, for the A here you got the 3, and then you can see that you got 4 B's in that series that way, in the same form as it is, right? So A plus B's minimum value in this case is going to be 3 plus 2. So the B as you can see became 2. So it's going to be 3 plus 2, which is equal to 5. And that's your correct answer. Option E is your correct answer. All right. So let's move on to the next question. Question 7. A set of 10 natural numbers, not necessarily different. So these are 10 numbers and they are natural numbers. All right. Okay. Have a mean and unique mode and median and range all as 10. Everything is 10. Find the smallest possible value of the largest number. All right. So let's understand what is a range. First of all, what is a range? Range is if you put a data set, okay, from in an increasing order, okay, increasing order, in that case, the largest number minus the smallest number is the range. That is, the difference of them is called the range. Okay. So if you have to find the smallest possible value of the largest number, okay, so let's say this is the largest number. The smallest number will be what? It will be L minus 10, correct or not? Right? It will be L minus 10, which means that the smaller the smallest number is, the smaller the smallest number is, the smaller will be the largest number, because if this is S, in that case, this one is S plus 10. Correct. All right. Now, taking this as a fact and also, taking the cue from the question that these are all natural numbers, we'll try and explore, because the smallest number can be 1. In that case, the largest number will be 11. That is 1 plus 10. Right? All right. So we'll try with 11 and we'll see if 11 can fit the bill of our answer, because that's one of the options as well. Okay. So we'll see that. Okay. So let's first look at the numbers here. So let's say this is the first number, second number, third number, fourth number, fifth number, sixth number, seventh number, eighth number, ninth number, and 10th number. And it is constantly growing. Okay. So this is the largest here. We have put them in ascending order, or in growing order. So this is the largest number. This is the smallest number. Okay. So these are the position of the numbers. These are not the numbers themselves, but these are the positions. Okay. Let me not put all this. Just put a line is enough. All right. Now let's see for the largest number here. Okay, because there are 10 numbers. The largest number, if I put here as 11. Okay, let's start with this and let's put the smallest number as 1 in that case, so that the range is 10. Okay, and now we'll need to look at the median. What is the median of a data set with even number of numbers? It will be the middle two numbers. Okay, so the middle two numbers average. So the middle two numbers are here, 5 and 6, and it's average. Okay, now what all options we can take? Either we can take a 10 and 10. Okay, why we can take a 10 and 10? so that the median is 10. Okay, 10 plus 10 divided by 2, the median becomes 10. Or we can take a 9 and 11. We cannot take a 8 and 12 because the numbers are in increasing order. The largest number is already 11 here, right? So you cannot have a 12 here, right? So these are the two possibilities, that you take a 9 and 11. Now, if you put a 9 and 11 here, all the numbers here, the 7th, 8th, 9th, they will also become 11. Because all are natural numbers. You cannot have anything more than 11, and they are in increasing order, so you cannot have anything else apart from 11. And therefore, you will have 4, 5 11s here. And then even if you put, and the numbers, you won't have a 10 also. Okay, so even if you put all the 9s here, okay, then what happens? That you don't get a 10 only, right? So if you put a 9 here and this one is 1 here, so what is going to happen here? Let's understand. Now, you got your median, but you are not getting your mode, because your mode, unique mode. Mode means what? The number which appears maximum number of times. So this particular option is not going to work. This one is not going to work. All right. Now what we'll go do is that we'll explore the 10 and 10. Okay. So if we have a 10 and 10, okay, let's say we have a 10 and 10 over here. All right. Now, for the mean to become 10, we need to understand that if we are distributing the numbers around 10, something is more than 10 and something is less than 10, and look at their deviation from 10, then all these deviations added up, the negative ones and the positive ones, should be 0. Now we start with here. This one has +1 from a 10, correct? These two are already 0. Okay. Now here you have a -9. Okay. Maximum value you can put over here in these numbers are 10s, because these numbers are in increasing order. You cannot put, and if you put more, let's say if you put 2, 3 or something like that, you'll have more negative deviations. But you have to balance it out. And here, at the most, you can put 11 in all the numbers, correct? If you put 11 also in all the numbers, the maximum positive deviation you will get total is going to be +4. It's going to be +4. But you have a -9. So how will you adjust that? Even if you put 10s here, which do not have any deviation from the mean, which are all at 0 deviation from the mean, then how will the mean become 10? Because if you add all this up, you'll see here it is 44, and here if you see it is 51. 44 and 51 is going to be 95. Right? And 95 divided by 10 will give you 9.5. The reason you will not be able to reach 10 is because here you have an excess of -5. Okay. -5. That's the reason why you have -5. So here it is +4, but you have -9 here. So overall, the deviation from 10 is -5 for the whole data set. All right. So therefore, 11 is not feasible at all. So our final conclusion is that 11 is not possible. So now we'll explore the next one. Maybe we are lucky. Okay, let's see. Okay. We'll explore the next possible largest number, which is going to be 12. Okay, in that case, the smallest number, give me a second, let me just clear this. In that case, we'll see the smallest number will be 2, and we have a 12 here. All right. Now try and again, let's try and explore this. We'll again explore in the same way. We'll have a 9 and a 11. And we'll have a 8 and a 12. This time we can have a 12 also. Okay, so if we put all of them as 12 over here, my deviation is how much overall? So how many 12s are there? First of all, I'll get 5 12s. If I get 5 12s, and already there is a 2, so there are only and another one is 8. So there are only 3 places left. Even if we put a 10, it cannot be a unique mode, correct? Because then the 12 will become the mode, right? So 8 12 is not possible. And using the same logic, again 9 11 is also not possible, because in that case, let's say I put all of them rest here as 12, or 2 of them as 11 and the rest as 12. Okay, let's see what happens. Okay, maybe this is possible. Let's see. Okay, so the maximum, so I cannot have a 10 here. So there's no 10 only. So the unique mode cannot be 10. So 9 and 11 are there, which means all the numbers to the left of 9 are going to be either 9 or lesser. All the number to the right of 11 are going to be either 11 or 12, right? So therefore the 10 is not there, so the 10 cannot be a mode. So for getting a 10, my only option is to have two 10s here. All right. Now let's look at the division again here. Here we have a plus 2. Here we have a minus 8 from 10. Okay, and these two are 0 already. All right. Now how much do I need to adjust over here? I need to adjust over here. I have minus 8 and plus 2 is going to be minus 6. So if I have 3 more 12s here, okay, my adjustment of positive deviation, negative deviation is done, right? And I have 4 12s. So I need more than 4 12s to get a unique mode. More than 4 12s, I need the 10s for a unique mode. So now I can have all of them as 10, which does not disturb the deviation also. So all of them will become 0. So now you can see that, okay, the range is first of all 12 minus 2. The range is 12 minus 2, which is 10. Median is average of the fifth and the sixth term, which is 10 plus 10 by 2, which is also 10. All right. What about the mode? The mode is going to be 10. Okay, because it's appearing 5 times. Okay. What about the mean? The mean, if you add it up, this is 48 and this is 52. The total is 100. Sum is 100 and divided by 10. My mean is also 10. So therefore, the smallest possible value of the largest number is going to be 12, which is option D. All right. So this is more of a logic. Plus, you need to be clear on the concept of what all are these terms. Okay, and then work this out. All right. So let's go to the next problem. Question 8. In the below figure, AB and CD are parallel tangents. Okay, to the circle of radius R, with A and C as point of tangency. BED is the third tangent with E as point of tangency. If AB is equal to 4, okay, and CD is equal to 9, then find radius. Okay, and so let's understand this question first. There are two tangents here, right? AB and CD, which are parallel to each other. So the symbol is given here for being parallel. Okay, so these two are parallel over here. All right, and AB is given as 4 and CD is given as 9. And BD is also a tangent. So when you connect these 2 points, okay, this is again a tangent at E. All right. And we have to find the radius of the circle. Okay, which the radius are. So we have to find the radius of the circle. All right. So let's understand this question first. First of all, let's understand we'll apply some simple rules. From a point when there are two tangents drawn, they are always equal. So there's a theorem around that. So you should be knowing that BA will be equal to BE. So BE will be also 4. And similarly, DC is 9. So DE will be also 9. Therefore, the total length of BD will become 4 plus 9, which is 13. All right. Now, let's understand. When there are 2 points of tangency and they are parallel here. Okay. So when you join AC, okay, it is going to pass through the center. Now, why is that so? Let's understand that. Okay. So let's say this is the center here, O, and you joined here. So there's a 90 degree here. And from the center again, if you join O, let's say this is not a straight line. Okay, so if this is not a straight line, and let's say if we are saying that this is not a straight line, okay, in that case, but the sum of these two angles is also going to be. So let's say if this one was going straight like this, okay, over here on the center, okay, in that case, this one would have been also 90, which means this angle would have been, this is an external angle, so this one would have been 90 plus some angle here. But if this one is same, because this one is then going to be 0, right? If this is 0, then this will be on the same line. And therefore, this is going to pass through this thing, right? So if there are two parallel tangents, they will pass through the center, okay? All right, now we got this. So half of this is going to be R and this side is also going to be R. Okay, now we are going to drop a perpendicular from B on CD. Okay, we will drop a perpendicular here. When we drop a perpendicular here, this is 90 degree here. This is also 90 degree here. This is 90 degree and this is 90 degree because the radius of a circle is at right angles to the tangent. Okay, and we are dropping a perpendicular, so this is also 90 degree. So automatically the third angle here will be also 90 degree because the quadrilateral has 90 degree. Therefore, this shape becomes a rectangle. If this is a rectangle, then AB will be equal to, let's say this perpendicular is coming at F. So CF will also become equal to AB, which will be 4. Right? And therefore, we can say FD will be equal to CD minus CF, which is equal to 9 minus 4 is equal to 5. Okay, now this is a right angle triangle. The hypotenuse is 13. Okay, and the base is 5. So this side BF, we can use the Pythagorean theorem, and that will be BD square. BD square minus FD square. So BD is 13, as we found out earlier, that is 169 minus FD. FD found as 5, so that is 25. Is equal to square root of 144, and that will be equal to 12. Okay, so BF is 12. Now understand, we established that ABCF is a rectangle. Correct. Therefore, we know that AC will be also equal to BF, which is equal to 12. But AC is nothing but the diameter. Therefore, the radius of the circle will be half of the diameter, that is 12 by 2, which is going to be 6. So your correct answer here is option B, which is 6. All right. So I hope this question is clear. Let's move on to the next question. Question 9. A prism and a pyramid have the same number of edges. Find the minimum least possible sum of their number of faces together. Okay, so there is a prism and there is a pyramid and their number of edges. Okay, edges are where two faces meet basically. Okay, any two faces meet, that line is called an edge. Okay, so let's understand what is a prism. Okay, a prism typically has, let's say, two faces on top and bottom with a polygon. Okay, so let's say there is a polygonic thing, and if we call it as a regular prism, so what will happen? Normally what happens is that the prism has same polygon at the bottom as well. Okay. Like this. Right. So there'll be a polygon here on top. This is the top. Okay. There'll be same identical polygon at the bottom, and the vertices are matched. A typical simple prism is like, for example, is a cube. Okay. A cube or a cuboid is a prism. Right. In that case, you see that there's a top face which has got 4 sides. There's a bottom face which there is 4 sides. Okay, and then there are the vertices. The top vertices are mapped to a bottom vertex. Okay, just below it. Okay, so what happens that if there are n sides in the polygon on the top face, let's say there are n sides in a prism, there will be n sides at the bottom also. Now these sides are edges. Okay, these are all edges. Why? Because two faces are meeting there. They're like the line, not the corners, but it's called an edge only. What can I say? I mean, the two faces are meeting, right? Okay. So there'll be n sides here. So these are also edges. And then there are n edges meeting these n vertices. So there are overall, the edges is, if the polygon has got n side on the top of a prism, the edges are 3n. Right? Let's keep this in mind. So edges are 3n. Okay. At the same time, there is a face on top, there's a face at bottom, and then there are n faces around it, wrapped around it. Okay, so there are n faces here. So for each side, there is one face falling down. Correct. So there are n faces. So the faces are n plus 2 typically. Okay, and the vertices here. All right, vertices is not being asked, but still I'm just sharing that knowledge. All right, so the vertices are going to be 2 times n. So there are n vertices on top and there are n vertices at bottom. 2 times n. This is for a prism. All right. Now let's look at a pyramid. A pyramid is a little different. Pyramid has got only one polygon at the bottom. Okay, and there is a top vertex which is then joined with edges with each vertex of the bottom polygon. So if the bottom polygon has n faces, n vertices, or n sides, whatever, because the polygon has same number of vertices as sides, in that case, the total number of edges here is there'll be n edges here at the bottom, in the bottom polygon, and there'll be n edges meeting with the top center uh, vertex. All right, because each one, from each vertex, it will be joined to the same top vertex. So the edges are 2 times n. What about the faces? The faces are again, there are n faces around, and there is one face at the bottom. So it is n plus 1. All right. Okay. And what about vertices? Vertices are also n plus 1 because there are n vertices here and there is one on top. Okay. So this is for a pyramid. All right. Given this information, now let's look at this problem. This problem says that a prism and a pyramid have the same number of edges. So let's say it's not saying that the polygons have the same number of sides. Because you see the formula are different. For the edges for a prism is 3n. For the pyramid it is 2n. Okay, so obviously the n and m have to be different for these two numbers to be equal, correct? So let's say for the pyramid it is n, and for this one let's change this to m. All right. So 2n is equal to 3m. All right. Now let's understand that if you look at the faces also, these are expressions in terms of m. So if the lower the m and n, the least the number of faces will be, which is our objective, to find the least possible sum of their number of faces. Okay. Now here we know that n minimum value we can take as 1, and n's minimum value for this equation to be correct, where n and m are integers, n is going to be 3 and m is going to be 2. All right. Now n is equal to 3 is still possible. Okay, you can have a triangle here, correct? All right, in the prism. But m is equal to 2 is not possible because with two sides you cannot have a polygon. Correct. So this one doesn't work. Right. So then we have to take the next multiple of their LCM, which was 6, as you can see, and work with that. So this one, then we can take it as 6. So n can be equal to 6 and m can be equal to 4. Now these two can form polygons, correct? Because 4 sides can form a polygon. 6 sides will definitely form a hexagon, right? And this one will form a quadrilateral. Okay. So now let's understand. So if we plug in these values for these respectively, the number of faces for the pyramid is going to be n plus 1. So that is going to be 6 plus 1, which is 7. And the number of faces for the prism, which is m plus 2, is going to be 4 plus 2, which is going to be 6. Therefore, the least number of faces they will have put together will be 7 plus 6, which is 13. And that's your answer. I hope you understood the logic behind this. All right, let's move on to the next question. Question number 10. How many 4-digit numbers are there whose sum of digits is 7? All right. So here we'll try and understand that how to go about this question. Okay. So if this is a 4-digit number. So let's say there's a 4-digit number. Okay. What are the rules here? Okay. So their sum is 7. So if we look at this, okay, what happens is that there are 4. So each of these boxes are separated. Let's say there are separators here. All right. Okay. And if we have something, let's say I have a 1 here, I have a 2 here, and I have 3 here. This is 6 plus 1, 7. Correct. All right. Now, if I shift this wall on this side, a little bit on this side, so that this one becomes 1, and this one becomes 4. So this guy now moves in over here. Okay. Now this is also 7. Okay, so we're going to use this concept. And also we know that the last guy here cannot be a 0. The guy on the extreme left, in this room, you cannot have 0. Why? Because 4-digit number cannot have a leading digits as 0. Right? So what we are going to do is that we'll take 7 here. Okay. The sum is 7. So if we put 1, 2, 3, 4, 5, 6, 7. All right. Okay. And then there are 3 separators as we saw. So we'll put 3 more. 1, 2, 3. Okay. Now let's understand. How we separate them, it becomes a number with a digit of the sum of 7. Okay. So let's say I put a separator here, I put a separator here, and I put a separator here. Okay. So these 3 points became separators. Okay. And whatever is in between is a number. So this one become 1. This one from here to here become a 3. This one is 2. And this one is 1. 1 plus 3 plus 2 plus 1 is 7. Right. So what is happening? There were 7 circles and there were 3 more circles which I drew, which were being used as separators. Now the only challenge is that you cannot have the separator in the first place. So every time I shift the separator, the number will be a different number. Okay, so let me give you another example here quickly. All right. So let me just delete it and redraw these 2 circles. 5, 6, 7, 8, 9, and 10. Right. Let's draw something else. Okay, so let's say I drew one here, and another one here. Okay, so this time this number is 3. There's nothing in between, so there is a 0. There's 1 between, so 1, and here you have a 3. So 3013, as you can see, the sum of the digits is 7. So as you shift the separators, they will form different digits, in different places, like the tens places. The digit between the first and the second separator will be the second digit. The digit, the number of circles to the left of the first separator will be the leading digit, which is the thousandth digit. Okay. The circles between the second and the third separator will be the third digit or the tens place digit, and the circles to the right of the last separator will be the ones place digit. So as you move them, the numbers will be different, but the sum will still remain the same. All right. Now, given this fundamental, and also the thing is that in this we also need to understand that 6, 7, 8, 9, 10. Also, we need to understand that you cannot have a separator here at the first digit, because as I said, if you have this one as the first separator, then this one becomes 0. Then if you put a number like this, it one becomes 0, 3, 2, 2. Okay, although the digit sum is 7, but this is not a 4-digit number. This is actually a 3-digit number, right? So you cannot have on the first one. So now, given with this knowledge, what we need to understand is that we need to select 3 separators, 3 plus 3 and 10. We need to select 3 separators except this one, the first one. Okay, so from nine circles, we need to select any 3 as separators. So that becomes 9 choose 3. 9 choose 3. And the way you can think about is that you select the first separator, there are 9 ways, 9 circles to choose from. Then you select the second one, you have 8 ways to choose from. Then you select the third one, you have 7 ways to select from. But in this case, you are actually counting them 6 times over. Why you're counting it 6 times over? Let's say you select these 3. Okay, the fourth one, the 6th one, and let's say the 9th one. All right. You selected 4, 6, and 9 in this way. But there is a possibility that you might have selected the 9 first, and then the 4, and then the 6. Correct? Okay. But still, it is the same separator. So the number will be the numbers in between will be the same, and therefore this can be arranged, as you know. So this is the same number. So if you have 3 numbers only, okay, the arrangement in the first place you can have 3 ways. The second place you can have 2 ways. In the third place you'll have 1 way. So you are actually counting these in 6 ways, 6 possible ways. So you have to divide this. 9 choose 3 is 9 into 8 into 7 divided by 1 into 2 into 3. So whatever is there, 3, you need to take the factorial of that. Okay. So 9, 8 into 7. So what do we get here? 4. This goes in 3 times. 3 times 4 is 12. 12 times 7 is 84. And therefore, there will be 84 4-digit numbers you can make whose sum of digits is 7. All right. So the correct answer is option D. All right. Let's move on to the next question. I hope this one is also clear. Next question is question 11, which is from the application ability section. How many years will it take for a loan of 100,000 to increase by 6.5 times at a quarterly 3-month interest rate of 2.5%? All right. Okay, let's understand that the interest is the interest amount. Okay, if it is a fraction, okay, the increase by 6.5 times. So it is increased by, increased to, no, we have to be very careful with the language. It's increased by 6.5 times. So what is the increase? This is the principal amount, right? This is the principal amount, which was the loan amount given to a person. Okay, now this one is increasing by this much time. So what is the increase? The increase itself is the interest, right? All right. So let's say the principal is P, and therefore the interest will be equal to 6/5 times of P. Correct? All right, it will be 6/5 times of the P. Now, how do we calculate the interest? The interest is, the formula for interest is principal into rate of interest into the tenure of the loan. So rate of interest for a particular, frequency of tenure, okay, multiplied by the tenure divided by 100, right? So it will be equal to 6/5. P is equal to P into the rate of interest is given as 2.5, and at a quarterly interest rate of 2.5%. How much time it will take? Correct. So we don't know the T here. By 100. Right. So P and P we can cancel out, and therefore the T will be equal to 100 times 6 divided by 5 into 2.5. 5 into 2.5. So the 5 will go in this 20 times. The 2.5 will go in this 8 times, and 8 times 6 is 48. So there will be 48. The tenure will be 48, right? But what is here? It is saying quarterly, 3 months. Okay, how many years it will take, right? So this is equal to 48 quarters. It is 48 quarters, because this interest rate is actually for every quarterly interest rate. So this is 48 quarters. Now 48 quarters means 48 3 months, right? So 48 quarters is equal to 48 into 3 months. And therefore, the number of years will be 48 into 3, and every year is 12 months. So 12 divided by 12. So we'll get 12 years. It will take 12 years for the loan to grow by or have an interest of 6/5 times of the principal amount. So your correct answer here is option B, which is 12. So you see that in this question, the principal is immaterial actually. The amount is immaterial. All right, we did not use that amount at all. All right, so let's move on to the next question. Question 12. A cyclist is going across a mountain and his uphill speed is 8 km per hour and his downhill speed is 32 km per hour. Okay, while going, he took 22 hours, and while coming back, he took 28 hours, and the routes were same. What is the total distance he covered all together? All right. So this is a question. We'll make the working space a little bit on the right side by making this a little smaller. All right. So let's first understand a few things here. Okay. So there is a hill, uphill is going, the cyclist is going up first, then down. All right. Here he's going, when he's going upwards, let's say this is point A and he's going to B. First he's going from A to B, and then he's coming back from B to A via C. Let's say C is the top of the mountain. Okay. If AC was equal to CB, then when he's going up at a speed of 8 km per hour, and then this distance he was going 32 km per hour. So this time will be, let's say, is 4 times 4t. Then this time over here, because the speed is 4 times of it, as you can see the relationship, the time would have been t. Correct. So the total time would have been 5t. Similarly, if these distances were equal, he would have gone this distance. He would have taken, while coming back, he would have taken 4t here, and coming back, he would have taken t here. So that time would have been also 5t. But here you see that the times are different. Okay, the times are different, which means that AC is not equal to CB. That is the first thing you need to understand in this question. All right. Because nowhere it is given that the uphill, while going, the uphill distance is same as the downhill distance while going. Okay. So let's understand this. So let's again draw this and understand this. So let's say when is going A, B, and C, when is going A to B and B to C. When he's going A to B, he's going at a speed of, let's say the time taken over here is going to be 4 times t1. The reason I'm using a 4 times t1 is because I see the ratio here is, the speeds ratio is 4:1. So I'm taking 4 times t1. Okay. And while coming down, let's say the time taken here is t2. All right. So A to B is, the time taken is 4 times t1. All right. And therefore, while coming back, so this is when he's going from A to B, A to B, and then to C. All right. So in that case, A to B is taking 40 times, and let's make a table here also. B to A and then A to C. Sorry, my mistake. It will be C to B and then B to A. All right. So A to B is taken 40. This was because his speed was 8 kilometers per hour. This is an uphill distance, correct? All right. Now let's look at B to C. Okay. And because he's coming at 32 kilometers per hour, let's take the time as T2. Okay. Now, in this case, while he's coming back, if he's taking T2 time to come down, if he's going back at a speed of 1/4 of its speed, which is 8 kilometers per hour, this one will become C to B will become 4 times T2. And then B to A will take T1 time, because then the speed is 4 times of the speed, correct? So here the total time, as we see, that 4t1 plus t2 is equal to given as 22. And here we see 4t2 plus t1 is given as 28. All right. What we are going to do is that we are going to get rid of one of the variables by multiplying the first equation by 2. That will help us because we can make the t2 as 4t2 by multiplying this by 4. We multiply this by 4, we get 16t1 plus 4t2 is equal to 88. All right. Now this one was our equation 2. We multiplied the first equation by 4 here. Okay. Now we'll subtract equation 2 from this. So we get 4t2 plus t1 is equal to 28. And when we subtract, we get rid of this. We get 15t1 is equal to 60. And therefore, your t1 is equal to 60 by 15, which is 4 hours. All right. Now, plugging in the value of t1 in the second equation, we can get the value of t2 as well. So 4t2 plus t1 is 4 as we got it. 4 is equal to 28. And therefore, 4t2 is equal to 28 minus 4, which is equal to 24. And therefore, t2 will be equal to 24 by 4, which is 6 hours. All right. Now we got both all the times. So now we can find the distance as well. So while going up and coming back, if you find one side distance, we'll be able to double that distance and find the total distance he covered altogether. Right. So 4 times t1. Okay. 4 times t1, he traveled. Okay. So he traveled for 4 into t1 Okay. And that is the time he traveled. And what is the speed was for that? That the speed for that was 8 kilometer per hour multiplied by 8. And then coming down, he traveled with a speed of T2. So T2 we found is 6 and the speed was 32. Correct. And that will be the total distance for while going. Okay. And the same distance will be there. And T1 here, as we know, sorry. So I need to put in the T1 also here, which is 4. All right. So we get 16 times 8 plus 6 times 32. So 16 times 8 is 128. Okay, plus we get here is 32 times 6, which is 192. When you add both of them, you get 320 kilometers. That is the distance he would have traveled. Okay, this way. We can check this will be the same thing for the return journey as well. We can check that by using the second equation here, which was 4 times T2. 4 times T2 would be 6. And he is traveling at a speed of 8 while he's going back. Correct. Plus, while going back, he's traveling 4 T2. Okay. So 4 times T2, which is 6, into 8, plus T1. T1 was 4. 4 times 32. Okay. And this will give us 24 times 8. 24 times 8. 8 times 24 is 192. Plus this is 128. This one is also giving us 320 kilometers. So as we can see that the distances are going to be same. Just wanted to double check on that. We found the distance of one way. Therefore, the total distance he covered is 320 plus 320. Or you could have done directly 320 times 2, which is 640 kilometers. And that's your answer. So the correct answer for this question is option A, 640 kilometers. All right. So that I hope you understood this question. Let's move on to the next question. Next question. Question 13. A wire is used to make a rectangular fence for the horse at a ranch. The wire is used for 3 sides of the rectangle and one side is a wall. As shown here in the picture, this side is the wall, the green line is the wall, and the wire is being used as a 3 sides of a rectangle. The area covered by this fence and the wall is 238 square meters, and one side of the rectangle is bigger than the adjacent one by 3 meters. Little Joe, who is very good with math, figure out that the area covered is not optimum given the length of the wire used. So he advised them to change the side lengths of the rectangle using the same wire and the wall. What is the optimum area one will get if they use Little Joe's suggestion? All right, so let's understand this first of all. So the wire is here, which is covering 3 sides. The length of the wire is not given here. The only thing which is given here is that the one of the sides, so there are 2 sides which are same, used by the wire, and one side which is a different side, again made by the wire. The third side, the fourth side is the wall itself. Correct. So the wall does not matter here. Okay, so we get 238 here. All right. So let's understand this. Okay, so let's say the area over here right now when they made the wall is 238 square meter. All right. And one side is bigger than the other side by 3 meters. So the area of a rectangle, as you know, is length times width. So let's say the smaller side is x and the larger side is then will be x plus 3. So x into x plus 3 will be equal to 238. Okay, so x meters into x plus 3 meters. All right, now let's solve this equation, which looks like a quadratic equation. So x square plus 3x is equal to 238. And therefore, x square plus 3x minus 238 is equal to 0. All right. Now, here we'll get that x square plus 17x minus 14x is minus 238 will give me 0. So I broke up the 3x into difference of 2 numbers so that their product is 238. 17 times 14 is 238. Okay, 17 times 10 is 170 and plus another 68 will give me 238. right? So here we'll get x into x plus 17 minus 14 into x plus 17 will be equal to 0. This gives us, if we take x plus 17 as common, that x plus 17 times x minus 14 is equal to 0, which means that either x plus 17 is 0, which will gives us x is equal to minus 17, or x minus 14 is 0, which will give us x is equal to 14. Now we cannot accept this solution because x is what? It is a length, right? It's the length of a wire. So that cannot be negative. So minus 17 is ruled out, which means the value of x is 14. And therefore the other side will be x plus 3, which is 17. All right. Now we have to again apply a little bit of logic here, that which side will take as 17, because we have to optimize the area now using the same wire. So the longer the wire, the bigger area we can get, right? So what we need to do, we need to understand that only 3 sides are being used of the rectangle using, the wire is being used only to make the 3 sides of the rectangle. And the 2 sides are the 2 different sides, okay, of different lengths. Adjacent sides are 14 and 17. So if we take these two as 14 and 17, okay, then we get a shorter wire. We get a wire total length of 40. 14 plus 14 is 28 plus 17, 45. Correct. But if we use the 17s here and the 17 here and the 14 here, then also my area is going to be same. 14 times 17, which is 238. But my wire is now longer. My wire is going to be 17 plus 17 is 34 plus 14 is 48. So we'll consider that wire length. So wire's length now we got as 48. All right. Okay. Now we are going to think that what little Joe's suggestion could have been. So we found the wire's length using the area. Okay, the maximum length. Okay, which could be there. Okay, because the question is asking what could be the maximum area which is covered. Well, let's understand. Okay, so we have this thing over here, and we have the wire on both sides. Okay, like this. All right. Now, if this whole thing is L, the whole wire length is WL, let's say. Then if I make a mirror image over here, I'll get 2WL, right? If I can put a mirror image beyond the wall, the total wire length will become 2WL, 2 times WL. I'm just taking a mirror image, as if there's water, there's a mirror image, right? Now, the area of this one, so the perimeter here is 2WL, correct? The perimeter here is 2WL. So if this area is maximum, then obviously this area will be also maximum. If 2WL is the area, this particular shape which you get, this particular rectangle which you get, which has a perimeter of 2WL, if its area is maximum, then half of its area will be also maximum, correct? And when can be this area be maximum? When it is a square. When it is a square, right? So, and we know in that case that if it is a mirror image, so this side is equal to this side, is equal to this side, is equal to this side. And these 2 sides are going to be equal, correct? Let's say that this is x, and this is x. Then this is x, and this is x. Then for this to be a square, this one needs to be 2x and 2x, because then only all the 4 sides are equal, correct? And then for a given perimeter, the square's area, for a given perimeter of a rectangle, the largest area is packed by a square, correct? If you look at this, for example, let's say there is a perimeter of 40 altogether. So what is half of the perimeter? The half of the perimeter is 20. Or let's call it a semi-perimeter. Okay. Now, if you split this in this semi-perimeter length and width into a 10 and 10, then you get the maximum area, which is 100. Okay. If you split this anything else, let's say you split into 11 and 9. Okay. Length and width and 11 and 9, you get 99. Then you split it further, let's say 12 and 8, it keeps on reducing, 96. Right? Then if you do it further down, if you go further down, 13 and 7. So the far they apart they are, the more rectangular they are in shape, okay, the lesser area they will pack. So square packs the maximum area. So now we know that the WL was 48. So we need to consider 2WL. 2WL is going to be 96. Correct? If 96, if we divide it by 4, what do we get? We get 24, correct? Each side will become 24 in that case. So this side will become 24. Yeah. All right. So this side is 24, then this will be 24. And this side over here will be 12 each. Therefore, the maximum area which you can pack here is going to be 24 times 24 divided by 2, or 24 into 12 also you can do, if you understood the concept. So that's going to be 240 plus 48, that is 288. Okay. So the correct answer for this question is option D, which is 288. Okay. Take a look at the question again. I hope this one is clear. Let's move on to the next question. Question 14. There is a row of 100 seats, and due to COVID-19, remember this particular GJMAT edition is from 21-22. At that time, the world was grappling with COVID. Okay, so it is not allowed for two people to sit together. No two people can sit at adjacent consecutive seats. What is the difference between maximum and least number of people who can sit in this row of seats, so that in each case no more people can join as per the rule for COVID-19? No more people can join. All right. Okay, so let's understand a few things here. Okay, if there are no two people who can sit adjacent to, on adjacent seat, which means that there has to be a gap of at least one seat between one empty seat between two consecutive people. Okay, so in that case, the number of people will be maximum. Okay, who can sit. So let's say we take this as number of seats here. So let me draw some seats here. Okay, and and let's say some seats here in the end. So this is seat 1, seat 2, 3, 4, 5, 6, so on and so forth. And the last one over here is going to be 100, 99, and 98. Okay. So if the first person comes and sits here, okay, let's say P1, okay, nobody can sit here, right? In that case, the second person can come and sit here, P2, and then again, if you leave a blank seat, then you can have P3 like this. And this will be the optimum or the maximum number of people who can sit. So you see that these people are all sitting on odd numbered seats, and all the even numbered ones are blank, right? So they will go ahead and sit till seat number 99, right? So how many people will be there? There will be 50 people in that case. This will be P50. Because there are 50 odd numbers, correct, from 1 to 100, and all these will be blank, right? Okay, because as you can see that if somebody sits in any of these seats which are marked as cross where people cannot sit, if the seat then if they sit over there, then they are adjacent to another person, correct? Because this one over here, for example, is adjacent to this as well as adjacent to this. So nobody can sit here. So the number of people maximum can sit here is 50, which is fairly simple to understand. Okay, what about minimum? All right, so what we are going to do is that now we are going to look at a minimum possible scenario. All right, I'm going to draw the same thing again. 1, 2, 3, 4, 5, 6, and so on, 98, 99, 100. Now let's understand that what if there is a gap of more than one seat? Okay, so let's say the first one person sits here. Okay, and then the second person comes and sits here. Okay, okay, and then again after two people, let's say on seat 7, another person sits here, P3, and so on and so forth. So 1, 4, 7 like that. If you notice here in this kind of pattern, we are leaving two seats in between, but one person, if a person sits here, he's adjacent to P2. If a person sits here, he's adjacent to P1. All right. So in this case also, it is not possible for another person to join if people are seated, already seated, are in this way, where they're leaving two seats and they're being extra cautious and they're leaving two seats in between and sitting one after the other. All right. So what we are going to do is that we are going to find out that how many seats will be there. Okay, like this. So what we'll do is that we'll try to minimize the number of people who are sitting, okay, by starting with the second seat itself. All right, because if the first person sits here, P1 sits here, or then this seat is also wasted because no one can sit here, right? Okay, but if the first person had sat on the seat 3, in that case, one person can come here and sit here in the end after all the other seats to the right are full. Okay, so we'll take the first seat as seat 2, and then we'll leave 2 seats, and then the second person will be on P2, and then the next one will be on seat 8, P3, and so on. Okay, so you see here the gap is going to be between any two consecutive person is going to be 2 seats, and if you look at the numbers, it's 5 minus 2, 3. It's a jump of 3 seats, right? So 2, 5, 8, like that, we'll keep on going. Okay, now if you notice that these numbers are 3's multiple because you're jumping by 3. So these are 3's multiple minus 1. So this is 3 into 1 minus 1. This one is 3 into 2 minus 1. This one is 3 times 3 minus 1, like that. So the last person who will sit here will be on 98, right? It will sit on 98, which will be 3 times 33 minus 1. So this one will be the 33rd person, E33. All right. However, in this case, we notice that there is a room for another person to join in. 99, no one can sit. Okay, but on the 100 seat, P34 can also sit. Right? Okay. So we got this, that the maximum number of people in this particular scenario, if they are ultra cautious and they sit by leaving 2 seats in between, then they'll be able to be 34. Okay. But in this case, we are actually, wasting 1 seat, which as compared to the previous case, and therefore the total number of seats will be minimum number of seats when nobody else can join anymore will be 34, right? So the maximum we saw was 50. So the difference of seats will be number of people who can sit will be 16. All right. So the question said that what is the difference between maximum and least number of people who can sit? So least number of people is 34, maximum is 50, and hence the difference is 16. The correct answer is option B, which is 16. All right. So let's hope, I hope you understood this solution. Let's move on to the next one. Question 15. 420 equilateral triangles of side length 2 each are joined together without overlapping to make a parallelogram. What would be the minimum perimeter of this parallelogram? Okay, so they're asking that what will be the minimum perimeter of this parallelogram. Now let's see first how the parallelogram can be made in the first place. All right. Okay. So let's say this is a equilateral triangle. Okay. If I join another one like this in an inverted fashion, I have a parallelogram, right? So we join two, okay, and we see that the perimeter in this case is going to be, let's say this is 2, side length is 2, each is going to be 8. Otherwise, it would have been 12. So 2 of them are wasted here because those two sides, okay, these 2 sides here went inside, correct? All right. Now, what we need to understand, we'll look at another concept here. Okay, let's say we have to make a bigger parallelogram. So we have one like this. Okay, now if this is one side, then the next one is going to be like this. Now this becomes a trapezium. Correct? This becomes a trapezium, right? Okay, because the side lengths are not equal. So I need to add another triangle here. Now this is also a parallelogram. Okay, and then I can have another one here joined here. So I need to replicate that, but just shift the corner over here on this at this corner. Okay, so I get another, this is also a parallelogram, correct? Now understand this, that what if I had taken this one in this way? Okay, so if I had taken this parallelogram, so I've used 4 triangles here, as you can see, 1, 2, 3, 4, 1, 2, 3, 4. Sorry, 8 triangles. Okay, so let's say if I had taken 4 triangles like this, then another one is 5, 6, 7, and 8. Here also I'm using eight triangles. Now let's look at the perimeter here. In this case, each side is 2. So here the perimeter is 2 plus 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 2. So we have each side of the parallelogram is 4. 2 plus 2, 4. 4 times 4 is 16. However, in this case, you will see that the perimeter here is 8 times 2, 16 plus 2, 20. So the more squarish the object is, okay, or more, equal sides are there in length, the more it will be, the less perimeter it will have. Okay, it goes just like the square also. So if you have squares also, okay, if you have 4 squares, for example, so if you join them like this, okay, with unit length, that's length 1, you get a perimeter of 10. But if you join them like this, okay, what happens? Your perimeter becomes 8. All right, because what happens? More sides go inside the figure, and therefore they reduce the perimeter. Okay, here there are 2 sides here, one from this one and one from this one. There are 2 sides here going inside. There are 2 sides going inside here. So overall 6 sides went inside. If you look at, if these all 4 squares are disjointed, then the perimeter will be 4 times 4, which is 16. But 16 minus these 6 sides, you get 10. But here, if you notice, okay, each one of them is losing 2. Okay, each one of them is losing 2 inside, correct? So, therefore, 16 minus 8 will be equal to 8. So, exactly the same fundamental, we are going to apply all these fundamentals in this problem, okay, and try and solve this question. Okay, now, one thing we also noticed when we joined the 8 triangles here, okay, in this way, where we saw that the side lengths of the parallelogram are equal, but in the row there were 4 triangles, correct? Wherein we are using 4 triangles in a row, correct? But the side length only 2 are coming up. Okay, but here in the column we are using how many triangles? We are using altogether 3 triangles, correct? Actually, we need to count it like this. The row is 4, and then we have two of the rows like this. So we have 2 triangles only. Okay, so we are using 2 triangles, right? Now, the overall we have 4 times 2, we have 8 triangles here. All right. So what we are going to do now is that, and the area therefore will be equal to the area of 8 triangles. So here we see overall there are 420 triangles. We need to split them up in such a way that the count of triangles in the row multiplied by the count of triangles in a column, kind of a slanted column, is equal to 420. All right. So if you look at factors of 420, okay, which are close to each other, you will see 30 times 14 will give you 420. All right. Now also you need to understand that in the row we need to have even number of triangles. Okay. So if you have 30 triangles in the row, so let's say you have like this, and in the end you have the last one is like this. Okay. And you have 30 triangles, then this side over here is going to be 15. 15 sides. There will be 15 sides. We saw in the previous one over here also, if we are using 4 triangles, we are getting 2 sides, correct? 2 side lengths. If we put 30, we will get 15 of them, and each one of them is of length 2. So the total length of this side of the parallelogram will become 30 again. All right. Now, if you have 14 rows like this, 14 rows like this, sorry, these should be like this. Okay. So if we get 14 rows like this, then this side length here is going to be 14 times 2, which is 28. All right. Now understand this. We have 30 triangles like this. So we have, this is triangle 1, and this one, last one will be triangle 30. We have 30 triangle, and like this, we have 14 rows. We have 14 rows like this. Okay. So 30 times 14, we have 420 triangles, which we have used up, and which are non-overlapping as well. Okay. So the side length over here will be 14. The side length over here is 15. Now you see that 15 and 14 are very close to each other. You cannot bring them any further closer. Okay, but each triangle side length is 2, and therefore the total side length will be 15 times 2, which is 30 units. And this one is 14 sides, so 14 times 2 will be 28. And the total parallelogram will be 2 times of this. So the perimeter of the triangle, the minimum, the parallelogram, the minimum perimeter of the parallelogram will be 2 times 30 plus 28, which is 2 times 58, and which is equal to 116. And 116, option E is your answer. All right, I hope you understood this. Let's move on to the next question. Question 16. Given the students are intelligent, the probability of them being naughty is 0.7. And given that they are not intelligent, the probability of them being naughty is 0.3. If the chances of any child at random being naughty is 1 by 3, then given a child is naughty, what is the probability of him or him being intelligent? All right. So we see that there are, the children are either intelligent or not intelligent. They are either naughty or not naughty. Correct. Okay. So they are a mix of all the kids. So we need to take the data here and try and solve this problem. One good approach would be to have a matrix here. Okay. So let's have a matrix here and then translate this. Okay. I will mark the intelligent one here as I on this axis. Okay, and the not intelligent one are this one. So I is this one, and not intelligent is this one. And then naughty is this one, and not naughty is NN is this one. Right? Okay, so what will be this particular quadrant? This is not intelligent, not naughty. This one over here is intelligent and not naughty. This is intelligent and naughty, and this is not intelligent and naughty. All right, now let's look at the first sentence of the question. The probability of them being naughty given that the students are intelligent. So the given that the students are intelligent is this particular section, correct? Is this particular column which we are looking at, correct? Them being naughty is 0.7, which means being not naughty will be 1 minus 0.7, which is 0.3. So let's take this as 7x. All right, if this is 7x, then this one will be 3x. What is the ratio? 7 is to 3, correct? This is intelligent. Naughty, if intelligent and naughty is 0.7, then intelligent and not naughty is 0.3. Correct? So 3x. All right. Now, given that they are not intelligent, the probability. So now we are discussing about this column. Okay, the probability of them is naughty is 0.3. So let's say not intelligent, because intelligent and not intelligent people are not equal. So we cannot take 3x here. Okay, but we can take a different variable, 3y here. So not intelligent but naughty is, let's say, 0.3. Then not intelligent and not naughty will be 0.7. Their probability will be 0.7. So that will be 7y. All right. We've got something here. Okay. Now here it says if the chances of any child at random being naughty, so any child being naughty, okay, is 1 upon 3. So now let's see what is the total number of children. The total number of children, as you can make out from here, is 3x plus 7x is 10x plus 7y plus 3y is equal to 10x plus 10y. This is your total number of students, 10x plus 10y. Right? And the naughty children are 7x plus 3y. Okay, so this is the probability of naughty children from all of the children. If you pick up any child at random, okay, the probability of them being naughty So the total number of naughty students divided by total students will be the probability of them being naughty, if any student being naughty. And this is given as 1 by 3. All right. So we'll try and solve this equation and find a relationship between x and y. So 3 times 7x is 21x plus 9y is equal to 10x plus 10y. And that gives us 11x is equal to y. Okay, so we got a value of y, which is 11x. Now what we'll do is that we'll put in the value of y in all of them and convert them into a single variable in all these 4 boxes. So 7 times 11x, this one will become over here 77x. All right. What about 3y? 3y will become 33x. Right. Now the question is asking that given a child is naughty, what is the probability of him is being intelligent? Okay. So how many, given a child is naughty, how many naughty children are there altogether? You can see there are 40 naughty children. Correct. 40x. Correct. These are the naughty children. Now, how many of them are naughty? How many of them are intelligent? 7x of them are intelligent. Okay. What is the probability of him being intelligent? So we take all the naughty children, and out of that we take the children who are naughty and intelligent. Correct. So that will be 7x. And this is what we need to calculate. Okay. So this probability is going to be 7 upon 40. And that translates to, if I put this, will be 0.175. And that's option A. And that's the correct answer. I hope you understood this. This was a fun problem. Let's move on to the next one. Question 17. A math test has 2 parts. The first part is worth 60% and the second part is worth 40%. If a student gets 95% of part 1 correct, what exact percentage student must the second percent correct? What exact percent correct must the student achieve on part 2 to average 90% of the whole test? All right. So let's understand this question. There's a test. Let's say the test is for 100 marks. Okay. Now there's a part 1 which is for 60 marks, and there's a part 2 which is for 40%. So it is 40 marks. Now, if the student gets in this 95%. So 95% of 60 is how much? So let's break it up. 90%, 10% of 60 is 6. 5% is 3. So 10% into 9, which is 6 into 9 is 54, plus 5% is 3. So he'll get 57 marks in this. Now, overall, to get a 90%, he needs to achieve 90, a score of 90. Correct. Overall, to achieve a percent of 90, he needs to get a 90. So how much he should get here? That will be the balance here, which is 90 minus 57, which is 33 marks, right? Now this 33 marks is of overall, correct, of this overall 100. But what is this 33 of 40? What percentage he should get of the second part? So we have to calculate 33 upon 40, okay, and that will be 82.5%. Because 10% is 4, 32 will be 80%, and if 10% is 4, then 1 extra marks will be 2.5%. The answer will be 82.5%, which is option C. Right? This was a fairly simple question so far. So we'll move on to the next one. Question 18. A group of children in village A had some marbles to play, and the marbles were distributed equally, with each kid getting 12 marbles. And at the end, 7 marbles were left. Later, some more kids from the neighboring village B joined them, but did not get any marbles with them. This time they were able to again redistribute the marbles equally, and each kid got 8 marbles, but still 3 marbles were left. All right. If the total number of kids together from both villages were less than 50, then find the maximum number of marbles which were there with the kids. All right. All right, so let's understand this. Let's say in village A, there were n kids. Okay. And put together village A plus B, there were total of capital N kids. Okay. So I'm using the small letter N, small case n, for village A kids, and put together A and B were n kids. So how many kids were in village B? It will be obviously n minus n. Correct. All right. Now, given the first one, we know that if the total number of marbles, okay, total number of marbles, let's say were m, that will be equal to, if each kid got 12 marbles, so 12 times n plus 7, right? Because every kid in village A got n marbles, got 12 marbles, and there were n kids. All right. And then there were 7 marbles left in the end as spare. The total number of marbles will be this. Now, village B, when the kids came in, the marbles did not change because they did not bring any marbles, right? But now the total number of kids are n, and the number of marbles each kid got was n, capital N. So 8 times capital N's, okay, and plus 3. So the total number of marbles, these two will be equal, right? Now, we need to understand in this case that if we do this, okay, and we do a 8 times n minus 12 times n and bring the constants on the other side, it will become 4. Right? So we have an equation here, okay, where n and n are the number of kids, so they are integers, okay, and we need to satisfy this equation. There is another restriction here saying that the total number of kids altogether were less than 50, okay. So your n here is less than 50. So n is less than 50. And it is asking you to find the maximum number of marbles which were there with the kid. Okay, find the possible maximum number of marbles which were there with the kid. Now you see here that the number of marbles is 8 times n into 3. It's a function of n. So if n is maximized, if this is maximum, the maximum can be 49. It cannot be 50, right? Then we get the total number of maximum marbles as well. All right. Okay. Now, but at the same time, this should also satisfy this equation as well. Okay. So let's do a little bit of trial and error and see what do we get. So if we do 8 times 49, which is the maximum possible value, plus 3. Okay. Or instead of that, let me plug in the value of 49 over here. Okay. And say that 8n is 8n minus 4 is equal to 12n. Right? Okay, from this equation, let's put n is 49. Now 49 times n, 50 times 8 is 400. So this one will be 392. 49 times 8. 50 times 8 is, so 49 times 8, 1 second, 49 times 8, yeah, it will be 392, and 392 minus 4 is 388. Is 388 a multiple of 12? We need to check this, okay, if this is correct or not. If this is correct or not. Okay, so 388 is 360 plus 28. Now 28 is not a multiple of 12. 360 is. Therefore, this one 49 does not work. Right? So we'll check another one, next one, which is 48. If we do 48, we'll get 8 times 48, that is 2 times 8 is 16. So it will be 384 minus this thing will be 380. Okay. Is 380 a 12 multiple? All right. So that's also not 12 multiple. It's not working out. Correct? All right. We'll go another one down. You look at 47. So we'll get 376 minus 4, which is 372, is equal to 12n. This one checks the box. So if you have n as 47, okay, n as 47, then this one is 372, and which means that n will become 31. Right? So the total number of marbles in that case will be 8 times 47, 8 times 47 plus 3, or we can say 12 times 31 plus 7. Let's calculate each one of them. So 8 times 47 plus 3, we saw that 8 times 37 will be 3, 47 will be 376 plus 3 will be 379. Okay. What about this one? 31 times 12. 12 times 31 will be 372 plus 7, which is also 379. Right? So 379 is the maximum number of marbles you can have, and that is option E. This problem is a little bit of a trial and error, and it also tells you that how you can use the conditions of the question. Let's look at the next problem. Question 19. If A and B work together, they take 20 days to finish a work. If B and C do the same work, they take 24 days to finish it. And if A and C do this work, they take 30 days to finish it. Find how many days they will take if all of them, A, B, and C, together do this work. All right. Okay. So in this case, we need to understand that, that A and B, if A and B do the work in 20 days, in one day, in 20 days, in one day, they will do 1 by 20 work. All right. In one day, they will do 1 by 20 work. Similarly, for B and C, in one day, they will do 1 by 24 work. And similarly, C and A in one day will take, let me see what is the number here, is 30. In one day, in one day they will do 1 by 30 of the work, 1 by 30 work. Correct. So let's see if we assume that there are two A's and two B's and two C's, then how much work will be get done in one day? Two A's, two B's, and two C's. So if we say 2 of A plus B plus C, if we add all these three up, we get 1 by 20 plus 1 by 24 plus 1 by 30 work they will do. Okay, so let's see what is this. So if we take the LCM is going to be 120. So 6 plus 5 plus 4 work. And this is equal to 15 by 120, which is equal to 1 by 8 work. Therefore, 2 of A plus B plus C will do the work in 8 days. Okay, if they do 1 by 8 of the work, 2 of A plus B plus C, then 2 of A plus B plus C will do the work in 8 days. Correct. Therefore, if we half it, obviously the resources is becoming half, the time will become double. Right. So A plus B plus C will do the work together in 8 times 2, which is 16 days. And that's your answer. So 16 is option number D. And that's your answer. Right. Let's move on to the next one. Question 20. In a language school of 90 students, there were 40 students who took up French, there were 35 students who were in the Spanish class, and there were 32 students who took up Russian. If there were only 3 languages and students can choose from at least any one to all 3 languages, then at most how many students were studying all 3 languages? All right. So first of all, let's look at some of the data here. The total number of students is 90 students. All right. Now, some of them who took French were 40. Out of the 40 students, maybe some took other subjects as well, other languages as well. Similarly, there were 35 who were there in the Spanish class and 32 who were in the Russian class. So if we add their list together, let's say there's a list of French students, there's a list of Spanish, there's a list of Russian students. Okay, if we add these numbers, out of which some might be common also, we will get the total number of students in these 3 classes, correct? So we'll get that French was 40, Spanish is 35, and Russian is 32. So if we add all this up, we get 107. 107 in the total list. Of course, there are some duplications. Some names might be in all 3 languages as well. All right. Now let's understand that the total number of students, let's say X students took only one subject, one language, one language. Y students took two languages, correct? So they will appear in two lists, correct? All right. They will be counted twice. Z students took all three languages. So they'll appear in three lists. They'll be counted three times in these lists. So what do we here? We get an equation here that X plus 2Y. Why we are doing 2Y? Because these will appear in two lists. Plus 3Z will be equal to 107. And the other equation, these lists are exclusive. The student who is doing one language cannot be the same students who are doing two languages, right? So X plus Y plus Z, that is going to be the total number of students, which is 90. Okay, when you subtract this, you get this cancelled and you get Y plus 2Z is equal to 17. All right. Now, in order to maximize Z, because your objective is that, at most, how many students were studying all three languages? At most. Your objective is to maximize this, right? Correct. So Y can be minimized. So if you put Y as 0, then what will happen? You will get Z is equal to 17 by 2, which is a not integer value. But these are count of students, right? These are count of students. So it has to be an integer value. So Y cannot be 0. Y cannot be equal to 0. Therefore, the minimum value of Y you can take is Y is equal to 1. If you take Y is equal to 1, then 1 plus 2Z is equal to 17, and therefore Z is equal to 16, and therefore Z will be equal to 8. Okay, so the correct answer for this question is option A, 8. There will be 8 students who can learn all three languages. See, if the 8 is more than all these three lists, correct? So if 8 students are common, then what will happen? So if you make a Venn diagram here, right? And if we put the Z3 here, okay, so these are part of all the three languages. Okay, only one student is doing two languages. Let's say the French, and the second highest was which one? Let's say the Spanish one. So this is French, this is Spanish, and this is Russian. Right. So if we put one student who's doing two languages, we put over here one. So then for French, which is overall was 40. So, and these are all zeros. Okay. So if we look at these ones which are doing two languages, these two are 0. Right. So 40 minus 8, you can have 32 students here. Right. And then the Spanish were 35. 40 minus 9, sorry. So 40 minus 9 will be 31 here. And 35 minus 9 will be 26 here. Okay. And 32 minus 8. The last one is 32. Russian is 32. Yeah. 32 minus 8. You get 24 here. Right. So this is how it will look like. Now let's add up all these numbers. What do we get? You should get 90. Okay. So 31 plus 1 is 32. 32 plus 24 is 56. 56 plus 26 is 82 plus 8 is 90. Right? Let me again do 32 plus 24, 56. And 26 is 82 plus 8 is 90. Yes, 90 students. So you see the maximum number of students who can learn all three languages will be 8. Is option A. I hope this one is clear. Let's move on to the next one. Section C. This is from the problem solving section. So these are non-routine problems. Question 21. At a Math Olympiad contest exam, there were 25 questions bearing 4 marks for correct answer, -1 marks deduction, negative marking for wrong answer, and 0 marks for unattempted questions. At most, how many students took this contest if only 2 students? At most, how many students took this exam if only 2 students got exactly the same score? Right. So this is a problem. There's a couple of concepts. Okay, and also involving pigeonhole. Okay, so let's understand this. Now, what is the total maximum marks of this exam? Total maximum marks Each question, 25 questions are there and each bearing 4 marks. So the maximum one can score is 25 times 4, which is 100. All right. Now let's understand what happens when somebody leaves a question. Let's say somebody attempts only 24 questions. Okay, and one question is unattempted. In that case, they will get 24 times 4, which is 96. So they go down by 4 marks if they leave a question, correct? But what if he attempted that question, but he got it wrong? Okay, so he would have got 25 into 4, which is 100. But because he got it wrong, okay, he did not get that. He did not get that 4 marks, and he also lost another extra marks. So he'll end up getting a 95. Okay, he'll end up getting a 95. I hope this concept is clear, right? So from a score of 100, okay, from a score of 100, assuming all are correct, one can go down by 4 or one can go down by 5. Okay, 4 in the case of unattempted and 5 in case of being wrong. Okay, now let's see what all scores are possible. Okay, what all scores are possible from 100. Okay, so is a 99 possible? 99 is not possible. 98 possible? It's not possible. 97 possible? Not possible. 96 possible? Yes, possible. We saw this. 96. So three are not possible for sure. What about 95? Yes, possible. What about 94? Again, not possible. How will you get a 94? Correct. No. So if you get, for example, you leave 2 questions or you get one wrong and one right. Okay, so you go down by 4 and 5. One wrong and one unattempted. So you go down by 4 and go down by 5. You get a 91. Correct. So there is actually a formula in this. Okay, let's understand this in another way. Okay, so let's say if I'm saying that on a number line, you're going from here by 4s and 5s. By 4s and 5s. This is a concept called also the McNuggets concept also, chicken nugget concepts also. So if you're going, if you either you take a 4 or you get a 5, and then you can from there you can again take a 4 or a 5. Similarly, from here again a 4 or a 5. So after a certain number, okay, you'll be able to make any combination with jumps of 4 and 5. Okay. So there's a concept. So how many numbers you cannot get? Okay, let's see this. So let's say if I make this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. So if you get a 5 and then you keep on getting 5, so you can land on any of these. Like for example, if you get a question wrong, then you'll get 95. Then if you get 2 wrong and you attempted all questions, then you'll get a 90. So you're going up by 5s, correct? So 5, 10, 15 like that. You're going down here from 100, 95, 90 like that. Here I'm showing in from 1 to 5. Okay, so then 5 plus 4, you get a 9. So 9, and then if you keep on getting 5s, you'll cover all these numbers, right? Because this is a grid of 5, right? Then 9 plus another 4 is 13. And then all the numbers below this you will be able to achieve. And then 13 plus 4 is going to be 17. You will be able to get all these numbers. And 17 plus 4 is 21. So you will be able to get all these numbers. So 4 also you can get, and 4 and then 5, all these you can get. And similarly, with 8, 4 plus 4 is 8, 8 plus, so you'll be able to get all these numbers. 12, you'll be able to get all these numbers. Okay, and then 12 plus 4 is 16, all these numbers. The numbers which you cannot get using a combination of 4 and 5 are 1, 2, 3, 6, 7, and 11. Okay. If you look at in this context, this question's context, 100 minus 1 is 99. 99 you cannot get. 100 minus 2 is 98. 98 you cannot get. 97 you cannot get. 100 minus 6, 94 you cannot get. You cannot get a 93 and you cannot get a 89. Okay. What about these? Yes, you can get these numbers. Okay. So anyways, you cannot get these 6 numbers. So there's a formula for this. Okay. That how many numbers? So the largest number you won't be able to form is 11. Okay. And the formula for this is if there are 2 co-prime steps like this, 4 and 5 are co-prime numbers, then it is 4 times 5 minus 4 plus 5. And that gives you the largest number you cannot get. So that's 20 minus 9 is equal to 11. And the number of numbers you cannot get is again, the formula for that is, this one was A into B minus A plus B. And the number of numbers, as you can see, are 6 here altogether. Sorry, this 4 is not there. This 4 is you can get, correct. 1, 2, 3, 6, 7, and this one. So there are 6 numbers you can see. For this, you have a formula called A minus 1 multiplied by B minus 1 by 2. In this case, A is, let's say, 4, so it will be 3, and B is 5, so it will be 4, 3 by 4 by 2, which gives you 6 numbers. So these 6 numbers you cannot get if you're coming back from hundreds, okay? All right, which means that you can go all the way from 100. Now, tell me something, how much the student least marks one can get? If they get all 25 questions wrong, if they've attempted, they will get minus 1, minus 1, minus 1, minus 1, minus 1, like that. So they will end up getting a minus 25 score. Okay. From 100, they can get all the scores in between 100 till 125, except these 6 scores. And this also, and these are all going to be integers, right? So the only, that also includes the non-positive and non-negative integer 0 also. So if somebody, let's say, just leaves all the questions, does not attempt any question, then you'll end up getting a 0, correct? So the total number of scores here from here to here is going to be 126, including the 0. So there are minus 1 to minus 25, there are 25 numbers, and 1 to 100, there are 100 numbers, and the 0 is another one. So there are 126 numbers altogether, which one can get if there was, but in this, these 6 numbers are not there. So these 6 scores are not achievable. So the number of scores which are possible for students, for any student to get, is 120 different scores. That covers the chicken nugget part. You can check on YouTube videos the chicken nugget math problem. You'll get a lot of videos around this. Okay, so that tells us that there are 120 scores which any students can get. Now it says at most how many students this contest if only 2 students got the same score. So let's say every student got a different score out of these 120 scores. Somebody got minus 25, then one other guy got minus 24. If you are arranging the scores in an ascending order, okay, minus 23 and so on and so forth till 100, except these 6 scores, there'll be 120 students, right? Now the 121st student, if he has to get a score, it will be out of these 120 scores itself. So that will be a repeat, correct? And therefore, if only 2 students got the same score, and then the maximum number of students will be 120 plus 1, which is option B, 121. I hope you understood this problem. This was a little lengthy because I explained the concept. Okay, let's move on to the next one. Question 22. Mike can climb steps in 3 kind of moves, 1 step or 2 steps or 3 steps in one go. What is the probability of Mike climbing a 10 steps staircase in exactly 5 moves? Okay, so let's understand, first of all, if there is no restriction on the number of moves, in how many ways Mike can climb these 10 step staircase. Okay, for that we will apply the Fibonacci concept. Okay, if you want, you can check the grade 7 video also. There's a similar problem to this, grade 7 or grade 6, I'm not sure. But let me explain to you one concept very quickly. If you let's say there are 3 points here, A, B, and C. Okay, let me write A, B, and C. And there's another point D here. If you reach A in 3 ways, okay, you reach here in 3 ways, as you can see. B in 2 ways, and C in 4 ways. And from there, you have only one way to reach D. From C also, you have only one way to reach C, this one is 4 here, okay, and one way to reach here from here. So if someone asks you to reach D, how many ways you can reach D if you can come only from A, B or C, how many total ways? So you'll add this up, because if you're coming from A, you're not coming from B. Okay, so these are all mutually exclusive. Therefore, you add all these up and you get 9 ways to reach D. Correct. Same concept, if we look at a staircase also, we can apply in this way. So let's say there's a staircase here, okay, any staircase in between. Okay. If I have to reach this point here, if I've reached this staircase in, let's say, 5 ways, 5 different ways I've reached here. Okay. And here I've reached in, and here I've reached in 3 ways, for example. Okay. And here I've reached in, let's say, 6 ways. Whatever way. Okay. So if I have to reach here, then from here I can take either one step and reach, and I can take one step or two step or a 3-step jump. Okay. So if I come from here, I'll take a 1-step jump and I'll come here. Right? So this will be all these 6 ways, correct, into one, correct? Not because it's a 1-step move, but because there's only one way, correct? All right. Now from here, if I to look at this, I've come 5 ways here and then again a 2-step move. This will be again 5 into 1. This one was 6 into 1. The last one will be 3 into 1, correct? So into 1 is not required. We need not multiply this. We can just add up these 3 and we can say that to reach here, if I reach here, the total number of ways will be 3 plus 5 plus 6, which is 14 ways. All right? Okay. All right. If at this step, we can take from all these movements. Okay. All right. Now, I understand these numbers are arbitrary numbers. This should have been ideally should have been an 8 or something like that. But I've just taken arbitrary numbers to explain the concept. So for the 10 steps, first let's understand how many ways are there if we are starting from step 0. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Let's say this is step 0. Step 0, when I'm at the right at the bottom before I even start climbing, there's only one way to be there. Step 1, I can take only one step, correct? If this is step 1, I can just come from step 1 by taking one step, right? So there's only one way. Now, step 2, I can either come from step 1 by taking a 1-step move, or I can come from step 0 by taking a 2-step move. So 1 plus 1, did you understand this? So let's say if I have to come here, I'll either take a direct step of 2, correct? Because step 1, okay, and from step 0 to 2, or I will do a 1 and then another 1, correct? There are 2 ways, so, which is this 1 way plus 1 way, 2 ways. Step 3, now because our friend Mike is allowed to take 3-step move also, I can come either from step 2 by taking a 1-step jump, or I can take a 2-step jump from step 1, or I can take a 3-step jump directly to step 3. So 1 plus 1 plus 2, it will become 4. And therefore, we keep on adding the last 3 numbers and make a Fibonacci series. Right? So 4 plus 2 plus 1 is 7. S5 will be 7 plus 4 plus 2 is 13. Step 6, I can reach in 13 plus 7 plus 4, which is 24. Step 7 will be 24 plus 13, which is plus 7, which is 37 plus 4, which is 44. Step 8 will be 44 plus 24, which is 68. 68 plus 13, which is 81. Step 9 will be 81 plus 44, which is 125 plus 24, 149. And step 10 will be 81 plus 44, which is 125 plus 149, which is 274. There are 274 ways altogether. And if you notice in some of the options here, you do have 274, correct? You do have 274 in some of the options. All right. Now the tricky part of this question, which is the probability part, okay, which says that if you take this in exactly 5 moves, if you take 10 steps, okay, then how will you reach? Okay, now the steps are always positive, so it's moving forward. Okay, so let's understand this. One way, which is very obvious, is going to be a 2-step, a 2-step, another 2-step, another 2-step, another 2-step. So 2 added 5 times is 10 steps, and you cover 10 steps. So this is only one way, right? So all are two-step moves, right? Now what we are going to do is that increase one of the twos, replace it by a 3, okay, and then make this a 1. So if I have a 3, 1, and then 2, 2, 2, all right? What happens in this? Okay, what I did, I replaced these two twos by a 3 and a 1. Okay. So now understand is that we need to also consider the order of moves. Okay. In what different orders I took the steps. Okay. So what happens here is that, okay, so in whatever way I take these steps, okay, I will reach 10th step. Okay. Either even if I take the one step here and then a 2 and then a 3 and then the remaining 2. So we have to kind of see how many ways you can arrange this. In this case, we see there are 5 altogether moves, out of which 3 are twos. So we'll do a 5, choose 3. Which position? So we are saying first move, second move, third move, fourth move, fifth move. So out of these 5 moves, okay, first, second, third, fourth, fifth, which 3 we choose for the 2? That will be 5, choose 3, and then for these two, we'll choose any one. Okay, so for the one, let's say one step move, we'll choose any one. So into 2, choose 1. So 5 choose 3 is 5 into 4 into 3 divided by 1 into 2 into 3. All right, and that's going to be 10 into 2 choose 1 is 2 only. So into 2. So that's 20. There are 20 ways I can arrange this. There are 20 ways. The first one was one way only. Right? Now we are going to do further, we are going to another 2, 3. So we'll take this one and we'll replace another one. 3, 1, 2. Right? Okay. So we are again going to, for the 3s, we are going to do a 5 choose 2. Okay. And then we'll choose another, out of the 3 places, we'll choose one place. Into 3 choose 1 for the 2. And the remaining 2 ones will automatically fit in, whatever is left. So this one will be 5 choose 2 is same as 5 choose 3. So this one will be 10 multiplied by 3. Okay, this will be 30 ways. And there is no more replacement which is possible of 2s. So basically, see, you can have at the most only 2 3s, 2 3-step moves. Because if you have 3 3-step moves, then you already covered 9 steps in that. And from 2 moves, you cannot have, for 2 moves, you cannot have just one step, correct? So maximum will be 2 and minimum will be 0 for 3-step moves. So 30 ways we saw for this configuration, 20 ways for this configuration, and 1 way for this configuration. All together is 30 plus 20 plus 1, which is 51 ways. Now understand, these 51 ways are also a part of these 274 ways. Correct. The remaining are maybe a 6-step move, or a minimum is going to be a 4-step move, right? Because which will be 3 3 3 3 1. Correct. And what will be the maximum? Maximum number of moves to reach 10 steps will be 10 ways, correct? Minimum 10 steps you can reach in 3 3 3 1 only, 4 move. And maximum can be 10, correct? 1 2 3 4 5 6 like that to 10 moves. So there are how many types of moves? There are 7 kind of moves may be possible. From 4 moves, 5 moves, 6 moves, 7 moves, like that, there are 10 moves. Okay, so there are 7 moves, out of which we are only considering only the 5-way moves, and that is 51 in count. So overall, the probability in that case will be 51 by 274. 274 was the total number of ways he could have reached the 10th step, immaterial of the count of moves. The correct answer here is option E, which is 51 by 274. I hope this one is clear. Let's move on to the next one. In the diagram below, ABCD is a rectangle and not a square. E is a point on AB and EC intersects the diagonal BD at O. The area of triangle EOB is 48 units and the area of triangle COD is 108 units. Find the minimum possible perimeter in units of the rectangle ABCD if the sides are integer units. All right. Okay. So let's make the figure a little bigger here. All right. So this is a rectangle and the areas are given as 48 and 108. So let's first of all understand in a rectangle, because the lines are parallel, this angle here is going to be equal to this angle. And similarly, this angle over here is going to be equal to this angle. And these two are vertically opposite angles. Therefore, by AAA, these two angles are, so triangle EOB is similar to triangle COD. Let's understand this first. If they are similar and their areas are of the ratio, if you notice the ratio over here, if you divide this by, this is 48, right? And this is, so if you, this is 12 times 4, correct? 48 is a 12 times 4. And this one is 12 times 9. Right? So the areas are in the ratio of 4 is to 9. 4 is to 9. Yeah. Let me write this. Area of EOB to area of COD is equal to 4 is to 9. And therefore, okay, in any two-dimensional things which are similar, okay, in that case, if the areas are of certain ratio, then their sides are of the square root of those ratios. Correct. So this one will be, therefore, this side is 2x, then this one will be 3x. Similarly, if this side is 2y, then this side will be 3y. And similarly, if this side is 2z, then this side is 3z. All right. Okay. Now let's take this as a vertex, and look at triangle COD and COB. Okay. So the height from this vertex is going to be common to this base, because the extension of the same base, they share the same base, and therefore, and they are in the ratio of 2 is to 3. If their height are common, then their areas will be in the ratio of the base itself, which is 3 is to 2. So this is 108, okay, which is 36 times 3. Then this one will be 36 times 2, which is 72. All right. So we already found 72. Therefore, 72 plus 108, which is triangle. So triangle BOC will be equal to 72, as we saw. Therefore, the triangle BCD, which is half of the rectangle, is going to be 72 plus 108, which is 180. Right? Therefore, the whole rectangle here, ABCD, because the diagonal always bisects the area of the rectangle, right? It divides the rectangle into two equal areas. So ABCD will be 180 times 2, which is 360. All right. Now we need to look at a length and width, because we are looking at a minimum possible perimeter. Minimum possible perimeter for a given area will be for a square, but a square is not possible because 360 is not a square number. It's not a perfect square number, right? We need to look at two numbers which are very close to each other. And in that we can figure out that those are going to be 20 times 18. 20 and 18 will give me a 360, right? Because if I take something else, okay, for example, if I take 36 times 8, 36 times 36 and 10, okay, this also gives me a product of, but in that case, the semi-perimeter is going to be 36 plus 10, which is 46. But if you look over here, it is the semi-perimeter here of the rectangle is going to be 38 only, right? And therefore, the perimeter will be, that is 20 plus 18 is 38. Therefore, the perimeter will be double of 38, which is 76. So the correct answer for this question is option A, which is 76. Right? So let's move on to the next question. Question 24. Green pastures is a huge grassland with 3 zones. Zone A has 2 acres of land and it takes 24 days for 10 cows to graze all grass there. Zone B has 5 acres of land and it takes 48 days for 15 cows to graze all the grass there. Assuming that the initial grass level and density is same in all zones and the growth of grass rate is same across zones and the grazing speed of all cows is the same, how many cows will be needed to graze all the grass of zone C in exactly 32 days, which has 8 acres of land? Okay, so let's understand a few things here. Okay, that more the area, more the grass will be there, right? If there is 2 acres of land and there is 5 acres of land, of course the 5 acres of land will have 2.5 times of the grass, correct? Initial grass to start with. Okay, all right. Now let's understand that. We'll fix up a few variable here. Okay, and let's understand the concept here. Okay, the concept here is, let's say there's a grass. The grass is also growing. Let's say the grass is there. Okay, the grass is also growing at a certain rate, and the cows are also eating the grass. Okay, if the growth rate of the grass is less than the cows eating speed, okay, then slowly and slowly the grass will keep on diminishing. It is just like saying two cars are there. Okay, there is one cow here, cow, car here called the cow. Okay, and there is another car here called the grass. Now this is a slower car. Let's say it's going at 40 kilometer per hour, and this one is going at 60 kilometer per hour. And at a certain given point of time, that distance is 100 kilometers. At this point of time, if I ask you in how much time this car will catch up with this car, you will take the relative speed, correct? 60 minus 40, which is 20. Okay, and you will divide by 100. So you will get in 5 hours this cow will catch up the grass. Okay, so this is the grass actually. This is the initial grass. So, so this grass will all get finished, correct? And this is the grass growth. The front car is the grass growth. Now, if you notice what happened exactly, that the front car, which was the cow, sorry, the grass which was growing, it traveled from the cow car. It was already at a distance of 100, right? And it traveled another 40 into 5, 200. So the total this one is 300, correct? And the cow also traveled 300 because it's 60 into 5 is 300, right? So we need to equate these two equations in this kind of problem so that we get this. Okay, so let's understand this. So let's say initial grass per acre is I. You put some variables here, is I. Okay, all right. Now the grass growth rate per acre is going to be G per day. All right, per acre. This one is also per acre. And the cow's grass eating speed is C per cow per day. Right? These are some of the variables which we have to set up in this question. Okay, I'll need to make this a little smaller so that we can have more working space here in this question. And we can refer to the question also. Now let's look at zone A. Okay, so zone A's initial grass will be, this is initial grass per acre. So it will be 2I because it's 2 acre land. Right, so it will be 2I. Right, that's the initial distance of the two cars. Okay, plus how much did the grasses grow? The grass grew for 24 days because till the time the cows are eating, it's growing, right? So it will be 24 days into how many acres? There were 2 acres, 2 into G. This is the amount of grass. This was the initial grass. This is the total grass, the growth of the grass. And this one will be equal to the grass eaten by the cows. So there are how many cows? There are 10 cows. And they are eating for how many days? They are eating for 24 days. And each cow has got a speed of C grass per day. Okay, C grass, sorry, I need to write this C grass per day. C amount of grass per day. So what did we get here? We got an equation which says 2I plus 48G is equal to 240C. All right. Be very careful in these questions while making the equations. Okay. All right. Now let's look at the second zone. This was for zone A. So we were dealing with zone A here. Let us do with zone B, and let me write it with a different color, zone B. All right. Now zone B has 5 acres of land. So that will be 5I of grass, initial grass. Correct. And how many days did the grass grow for? It grew for 48 days because till that time the grass was growing, till the cows grazed it up, right? So it will be 48 times 5 because 5 acres is there, correct? Okay, and multiplied by G is equal to, in this case, there are 15 cows. So 15 cows for how many days? For 48 days, okay, into C. So what do we get here? We get here another equation which is 5I plus 240G is equal to 48 times 15. So 480 plus 240, 720 C. Right? Initially, what we need to do is that we need to establish a relationship between the grass's speed and G and C. We need to get rid of the I. Okay. So we are going to multiply this by 5 and this by 2. Okay. So when we multiply this equation by 5, okay, what do we get here? We'll get 10I plus 240G is equal to 1200C. Right? And when we multiply this one by 2, we get again 10I plus 2 into this 480G is equal to 1440C. This becomes equation 4 and this is equation 3. So if we do a 4 minus 3, equation 4 minus 3, okay, what will we get here? So this one, these two will cancel out. Okay, 480 minus 240 is 240G will be equal to 240C. That's very interesting. So G is equal to C. Correct. So G is equal to C. And that helps us a lot. Okay, so now what we are going to do is that we are going to plug these values to find the value of I. Okay, so G is equal to C. So we are going to take the first equation. Let's take the first equation over here from zone this one. So we get here 2I plus 42, 48G. G, let's replace it by C. So we get 48C because G is equal to C, we established here, is equal to, we get 240C. Correct? All right. Right. So we have 2I is equal to 240 minus 48. That is going to be 192C. Correct. And that gives us that I is equal to 192C divided by 2, which gives us 96C. Okay. All right. Now we are going to plug in all these values and find our final answer for zone C. So let's look at zone C. Zone C. All right. So what does zone C say? Zone C has got how much land? Zone C has got 8 acres. So it is going to be 8I, correct? Initial grass is 8I plus it says how many days it will take for 32 cows to eat it. In exactly 32 days. Sorry, how many cows it will require? In 32 days. So if the grass is growing for 32 days, okay, we need to find the number of cows in this question. Number of days is given, but we require how many cows, how many resources are required. So now let's understand in 8 acres, it will be 8 into 32 days, the grass is growing into G. And this will be equal to 32 into, let's say there are n cows required who finish the grass, into n into C. Right? But here what we can do is that will take these values of I and C and G and replace by C. So here we'll get 8 times 96C plus 8 times 32 into C is equal to 32 into N into C. Right? So the C can be cancelled out here. Okay, and therefore the N will be equal to 8 into 96 plus 8 into 32 divided by 32. 32 will cancel. Okay, and this one will go in this 3 times, so it will be 24. Okay, so let me just break it up. I will get confused sometimes. This is 8 into 96 by 32 plus 8 into 32 by 32. So we'll get overall here is 24 plus 8 is equal to 32 cows. All right, just let me check the answer for a second in this. The answer key. Yes, that's the correct one. So 32 is the correct answer, which is option E. Right, so that's your option E. Okay. So I hope you understood this problem. I'll again tell you that you need to keep in mind the area because it is always proportionate to the area. So the area will play a role in these equations. That is number one. You need to get rid of the I, establish a relationship between G and C. That is the the grass growth rate and the cow's grass eating rate. Okay, and each cow's grass eating rate. And then once you establish that in terms of each other, sometimes this G might be greater than the C also, or it can be smaller than the C also. Depends. Okay. So then you need to take these values and then put in over here to find the initial grass. Okay. All right. So as we figured out that the number of cows which we took as n is going to be 32 cows, and that's your answer. So that's option E. Let's move on to the last question of the paper. A car starts from town A towards town B at a constant speed, and at the same time, a motorcycle at another constant speed starts from town B for town A. They cross each other at 56 miles from town B. They reach their respective destinations and turn immediately back towards their starting points. And this time they cross each other at 24 miles from town A. What is the distance between the two cities in miles? All right. So we'll do this problem. Okay. All right. Let's understand this. So you have here a town A and you have a town B here. Correct. The bike starts from here and the car starts from here. Okay. So what happens the first time they meet, let's say they meet here at this point, okay, and the bike has come from here to here. And this point here, let's call it as C. This is C to TB is given as 56 miles, which means that the bike has traveled 56 miles. Okay, and let's consider the total distance between the two times as D. So bike plus the car, totally together they have traveled a distance of D. All right, out of which the bike has traveled 56. So there would be some ratio of the car's speed and the bike speed, and the distance ratios will be also same, right? Okay, all right. Now let's understand. Now the bike here has moved here and then come back here, and let's say and whereas the car has moved all the way till here and has come back here. Right. So look at their return journeys. They put together the return journeys for the bike from town A till this point. Let's say call this point as D. Okay. The return journey from TA to TD for the bike, and for the car from TB to D is a D. Is D. Just like the previous time it is a D. And they covered one lap each together. So the total distance traveled by bike plus car. Let me not call this D because D is the distance here. Let me call this as E. All right. So the total distance traveled by both of them when they meet the next time E, which is at a distance of 24 miles, is this time is 3D. Why? Because the bike went all the way till here and then came back this much. The car went on the way this time this much, which is D, and then came back this much. So in the meeting during the return journey, the total distance traveled by them during the return journeys is D, and each one of them covered D distance before that, right? So total distance is 3D, right? So let's understand, in that case, the bike would have covered also 3 times of this distance. If bike's contribution in D is 56, then in 3D, its contribution will be 56 times 3, which is going to be 168 kilometers. All right. Now, 168 kilometers is actually the bike went all the way D and then came back 24 kilometers. So it's 168 is equal to D plus 24. Therefore, the distance D here is 168 minus 24, which is going to be 144 kilometers. And that's option E. And that's the correct answer. I hope this is clear. All right. This was a fun problem. All right. So that brings us to the end of grade 8 solutions. I hope you liked the video and you learned something out of it. If you like the channel, please go ahead and subscribe the channel and press the bell icon for further notifications on more videos. Thank you very much for your time and patience. All the best. Bye-bye.